Across the cold void, something impossible is happening. The latest data reveals 3i Atlas, a visitor from another star, is erupting with jets of water nearly 40 kg by second, all while stranded farther from the Sun than Mars. Even the swift ultraviolet and optical telescope UVO caught a surge of OH molecules, evidence of liquid activity where space should be silent and dead. No previous interstellar traveler, not even Oumuamua or Borisov, has broken the rules this spectacularly. The consequences ripple through physics. Either our textbook on comet behavior is fatally flawed, or Atlas is showing us chemistry never seen in this solar system. So why does this object look so uncannily alive out here? And what exactly are we missing? The figure is staggering, 40 kilograms per second. That is the measured water loss from 3i Atlas, not at the warm heart of the solar system, but stranded 3.51 astronomical units, AU, from the Sun, a distance where sunlight is normally too weak to coax water from most comets. The swift UVO, orbiting high above Earth, caught the unmistakable ultraviolet signature of hydroxyls, OH, a fragment of a water molecule torn apart by sunlight at a rate of approximately 1.35 1027 molecules every second. This unambiguous result confirms that 3i's Atlas is venting water at a rate that rivals comets much closer to the Sun, fundamentally rewriting what physicists thought possible in the deep cold. Normally, comets wait until they are much nearer, about 2 AU or less, before water ice starts to sublimate in earnest. But the numbers from Atlas demand a complete rethink. To sustain this massive outflow, at least 8% of its surface must be active, far more than the 3 to 5% typical for our homegrown solar system comets. The vast cloud of gas and dust surrounding it, the coma, is not just a thin veil, but a thick, dynamic envelope. The water paradox is solved, in part, by the extended source model. The water is not simply boiling off the solid nucleus. Instead, it seems to be coming from icy grains, tiny debris ejected from the nucleus, each one a miniature steam vent drifting in the coma and flashing to vapor under faint sunlight. This changes the rules of cometary activity, suggesting the object is surrounded by a halo of small, sunlit grains that collectively contribute to the massive outpouring. The comet's activity curve, reconstructed from archival photometry and ultraviolet spectra, rises where models expect it to fall flat. 3i Atlas now stands as a profound challenge to comet science, a visitor from another star breathing in the dark, its secrets carried in every molecule of water slipping into the void. Part I, 3 visitors, 3 impossible stories. The stark contrast between 3i's Atlas and its 2 predecessors illustrates just how strange this visitor truly is. The first interstellar visitor, one Oumuamua, swept through in 2017 as a silent, tumbling shard, bone dry with no coma, no tail, and no detectable water or carbon monoxide. It offered only its odd shape and baffling acceleration. 2 years later, 2i Borisov arrived, looking and acting like a classic, predictable comet, complete with a coma and tail that matched the familiar blueprints of solar system wanderers. It was a comfort, proof that some interstellar objects played by known rules. Then came 3i Atlas, and the rule book fell apart. Instead of a slow, steady rise in brightness, Atlas's light curve shot upward like a flare, a super, linear surge that outpaced predictions by a wide margin. This was not the gradual thaw of surface ice. It was a sudden ignition by something deeper and more volatile beneath the crust. As Atlas brightened, its coma shifted from dusty white to an eerie, luminous green, the classic fingerprint of cyanogen, CN radicals. But unlike Borisov, where CN appeared early, Atlas held back, then unleashed its green emission in a sharp burst, as if a chemical switch had been thrown deep inside the nucleus. This hyperactive, chemically restless behavior makes Atlas a new archetype, one whose super, linear brightening and delayed green glow challenge every existing model of cometary behavior. Part Hasiri, the chemical signature of alien engineering. The chemical profile of 3i Atlas reads like a manifesto of non-local origin, presenting 2 critical anomalies that defy simple explanation. Anomaly 14. Nickel without iron. The phrase, nickel without iron, has been echoing through comet science channels since the Very Large Telescope. A VLT caught 3I Atlas's coma lit up with atomic nickel lines, while iron, its expected companion, stayed hidden. In every solar system comet studied so far, iron and nickel travel together, usually in a predictable 10:1 ratio. On Atlas, nickel stands alone. This is a metallic fingerprint that shouldn't exist, while some modelers argue for exotic chemistry, like nickel-forming volatile nickel carbonyls that break apart more easily than iron compounds. No single mechanism perfectly fits the data. The isolated nickel lines hang in the spectrum like a challenge, suggesting Atlas's chemistry is more revealing and stranger than any comet seen before. Anomaly 2E, the CO2 dominance near infrared spectra from the JWST and ground-based telescopes revealed something almost unheard of. The amount of carbon dioxide, CO2 outpaces water vapor, possibly making CO2 the dominant volatile in the coma. For comet chemists, this is a red flag. In the solar system, water is king, but here, the numbers flip. This high CO2 to water ratio means Atlas likely formed in an environment much colder than the birthplace of most comets we know. Only in the deep freeze of an outer disk or under a dim, low UV star could so much CO2 survive locked in the ice. This odd volatile mix, combined with the delayed CN flare, paints a picture of a comet formed far from the warmth of any sun in an ancient, cold disk. The story written in Atlas's cargo is about an alien birthplace, not local geology. Part IV, Galactic Clues and the Technological Whisper. The extreme chemical signals of 3I's Atlas are not just chemical oddities. They are a fingerprint from another corner of the galaxy, a clue to the processes that shaped its parent system. The nickel anomaly, in particular, carries the memory of supernovas and stellar lives. To fully read that message, astronomers need to measure isotopes, a task for the next generation of giant telescopes, which would determine whether Atlas's nickel comes from ancient supernova debris or quieter, long-lived stars. The possibility that such a sharp, isolated nickel signal could be artificial, a technosignature, is a persistent whisper in the scientific community, even as most researchers push back, pointing to exotic, albeit natural, chemistry. However, the standard remains extraordinary claims demand extraordinary testable evidence. For now, 3-eyed Atlas acts as a galactic messenger, inviting us to map the chemical diversity of worlds beyond our own. As new surveys like the Vera Rubin Observatory and the Square Kilometer Array SK prepare to scan the skies, the case of 3-eyed Atlas highlights the urgency of turning fleeting encounters into lasting knowledge. The era of accidental discovery is ending. The challenge now is to catch these messengers in the act, to analyze their unexplained anomalies with rigor, and to finally unlock the chemical record they carry from another star. Each interstellar visitor is expanding our understanding of the galaxy's diversity, one documented mystery at a time.